Today's lesson is called Riemann Sum, approximating the area using midpoint. So last time we talked about lowest and upper sum. So let's talk about lowest sum first using the three rectangular shape. So let's pretend that here's the width, equal length. Using the left side of it, we should be able to sketch the rectangular shape. So once again, here's your left point once again. So you can see that in this case, left point will produce under approximation. So this is the area that you're going to find. And we can see there's a gap producing a lower sum. Additionally, we talked about upper sum. So in this case, we'll be using the right endpoint. Again, same condition, using three rectangular shape. So when we have the right endpoint, we over approximate it. We have more than what we needed. That's what we call that upper sum. Today's goal, again, is using the midpoint. So if the left endpoint produced the under approximation, right endpoint produced the upper sum, which is the over approximation. So if you use a midpoint, it should balance it out a little bit, because the mid sum is supposed to be between lower and upper. So let's look at that visually. So same condition, n equal to 3. Let's say here's an equal width. Now we're going to use a midpoint of these width to create a rectangular shape. And as you can see here, some pieces is over or outside of the range that we want to calculate, and some of them are under. So this little piece will cover this, that little piece will cover that small area that's under, and this big piece will cover whatever is missing over here. So whatever is over approximated will fill in the gap. So the midpoint, it will be a little bit more accurate approximation compared to the lower and upper sum. So let's look at example. Example 1. Using 4 midpoints of rectangles to approximate the area of the region lying between the graph of negative x squared plus 4, x-axis between x equal to 0 and x equal to 2. So I'm just going to sketch it first. So let's pretend here is your x-axis. And we have a big parabola. Here is 2. And the other side will be negative 2. Up here is 4. It has to be equal width. So we talked about how to calculate this before. Between the space of 2, we try to fit in 4 rectangular shape. So it's 1/2. But in our case, we have to find the midpoint of those widths. And the width in this case happened to be 1/2. The midpoint of 0 and 1/2 is 1/4. So we're going to use 1/4 to approximate it. And the midpoint of 1/2 and 1 is 3/4. And we're going to use that to approximate it. And 1 and 3/2 is 5/4. So somewhere around here. So I'm going to draw a rectangular shape. And the last one is 7/4. Again, roughly you can see that the little gaps are getting covered by the over approximation. Right, this piece is going to cover that. That small little piece that's over is going to cover this gap, and so on. And the setup is pretty much the same as the lower and upper sum. The width is equal distance, so it's 1/2. And they will all points, the midpoints will have a pattern, which width happen to be 1/2. So the sequence for the midpoint is similar as left and right endpoint. Is a plus delta x times I minus 1/2. So if you remember, right endpoint was I minus 0, which is also known as I. Left endpoint was I minus 1. And the midpoint is in between that, so it's I minus 1/2. So for this problem, it'll be 0 plus 1/2 times I minus 1/2, which we could simplify to I minus 1, 2I minus 1 over 4. This is your sequence. So if I is equal to 1, you'll find that it becomes 1 times 2 minus 1, so it's 1/4. Again, as you can see, it's 1/4. When I is number 2, so second rectangle, is 2 times 2, which is 4 minus 1, 3 over 4. So it works out with our sequence. Again, we want to have 4 rectangular shape. So f of our sequence, which happens to be 2I minus 1 over 4, will get us the midpoint. So 1/2 sigma of I equal to 1 to the 4 negative 2I minus 1 over 4 square plus 4. If you multiply this out, you should get negative times 4I squared minus 4I plus 1 over 16. And I'm going to convert this 4 into denominator of 16. That's how it becomes 64 over 16. So 1 over 16 could be factored out. So you have 1 over 32 because we factor out 1 over 16. This should leave you with negative 4I squared plus 4I plus 63. So now we have the sigma. We could just solve this out to find our area. So 1 over 32 negative 4 times 4 times 5 times 9 over 6. 4 times 4 times 5 over 2 plus 63 times 4 . 9 over 6 is 3 over 2. Right? 4 over 2 is 2. So we have 4 times 2 times 5 times 3. So 8 times 5, which is 40. 40 times 3 is negative 20, 120. 4 over 2 is 2. So we have 8 times 5, which comes out to be 40. And the last one, 63 times 4, comes out to be 252. Add them up and divide by 32. So it should come out to be 172 over 32. And this is divisible by 2. In fact, 4. So the answer comes out to be 43 over 8 as your area. So area using the midpoint, using 4 rectangles, it comes out to be 43 over 8. Now next example, so in this example, we want to find the midpoint. They want us to find when there's 2 different rectangular shape. When n is equal to 5, so now they're using 5 rectangular shape. B is when you're using 8 rectangular shapes. So instead of doing separately, we're going to solve the entire area as n and substitute those values in, where n in this case for A will be 5, for B n will equal to 8. So because we want to find the rectangular approximation of x squared plus 2 between 0 and 2, we could say the width is 2 over n. Again, we don't know how many rectangular shape that we're going to put in, but it's whatever the rectangular number we have is going to be divisible by that. And since we're using the midpoint, it'll be a plus delta x times I minus 1/2. A in this case was 0. Delta x was 2 over n. I minus 1/2. So our sequence comes out to be 2I over n minus 1 over n, which you could think that as 2I minus 1 over n. So here's our width, 2 over n. We're starting at first rectangle. Again, we don't know how many we're going to have, so I'm going to put as n. F of 2I minus 1 over n is our sequence. So 2I minus 1 over n to the second power plus 2, because it's x squared plus 2. So we have 4I squared minus 4I plus 1 over n squared. Once again, I'm going to put this as a common denominator, so 2n squared over n squared. Again, n is a constant, so we could factor that out. So it will be 2 over n to the third power, sigma of I to n. And you're left with 4I squared minus 4I plus 1 plus 2n squared. Now we could solve this out as n. So it would be 2 over n to the third 4 times I squared was n times n plus 1 times 2n plus 1 over 6. I was n times n plus 1 over 2. 1 in this case is 1 times n. Again, 2n squared is a constant, so 2n squared times n. Now we just have to simplify this. So we have 2 over n to the third. We have 4 over 6, which is 2 over 3. And if you multiply them out, you should get 4n to the third plus 6n to the second power plus 2n over 3. 4 over 2 is 2, so you have 2n squared minus 2n plus n plus 2n to the third. Combine the like term, then you should be left with 10 over 3 n squared n to the third plus 5n. Which it comes out to be 20 over 3 plus 10 over n squared. So this is your midpoint area. So we said the midpoint area for n equal to question mark was 20 over 3 plus 10 over n squared. So now we just have to solve for it. When for part A, they're asking you to solve for when n is equal to 5. So area has to be 20 over 3 plus n being 5, so 10 over 5 squared. So 20 over 3 plus 2 over 5. With the common denominator of 15, you should get 106 over 15 as your area. Part B, they want to solve it as n equal to 8. So the area is 20 over 3 plus 10 over 8 squared. So 20 over 3 plus 5 over 32. So once again, common denominator. So in this case, common denominator would be 96. And the numerator will come out to be 655. 106 over 15 is approximately 7.067, and 655 over 96, it comes out to be 6.823. If you sketch the graph of n equal to 5 and n equal 8, you'll find that n equal 8, having 8 rectangular shape, will produce a little bit more accurate answer, because the rectangular shape, more you add it, the gap, whether it's under or over approximate, will get smaller and smaller. So if you're just comparing using 5 rectangle compared to 8 rectangle, the real area will be closer to n equal to 8. In this case, will be 655 over 96. So we talked about before, delta x is the width of rectangular shape, where b minus a over n. If you have a question where they ask you to solve multiple questions, I strongly recommend leaving n as a variable and solve it out just like we did in example 2. The sequence for the left endpoint we talked about to be a plus delta x, I minus 1. Right endpoint was a plus delta x times I. Midpoint has to be somewhere between left and right. In fact, right in the middle, so that's why it becomes I minus 1/2 as a sequence.